Oh, you can't see anything. Okay. It's not usually cranked like that. That's weird. Okay, before we get started on like the actual nuts and bolts part of the review, I just want to go over a few things. So I'm making this video for both classes. My Monday class, yesterday I was sick, so I didn't have a lecture for them. So I'm making a lecture for the Monday and Wednesday and the Tuesday, Thursday class. So after this, I'm going to go directly up to my office and import the test into Blackboard. So it'll be open by noon. This is Tuesday, the 20th. So it'll be uploaded by noon, and then you guys will both have until, I'll give you until Thursday to take the test. Okay, so I'll give you at least really almost 3 days, 2.5 days to take the test. And so if you have any questions about that, let me know. It's going to be very straightforward, very similar to the previous test. And the structure, right? You have an hour and 15 minutes to take it. Multiple choice. Once you take it, you have to finish it. All that stuff. This isn't our first test this semester, right? So we should be fine. All right. So before we get started on just the overall review for the class, or for homework questions or anything like that, do you guys have any questions about the test? Come back here. Look, it's an Inception lecture. Here, let's see if that will. But there's me in the background. Okay, that's great. So let's just start on a good review. I know I missed the 3.4 for you guys, right? Or was it 3.4 that I missed? Yeah, you guys had to, because you're the Tuesday, Thursday. I was out Thursday for the that meeting, and that was the section 3.4. So yeah, I missed 3.4. So let's start there. If you have any questions about 3.4, let me know. Or when we get to it, when I'm going through the review, let me know. And that way I can sit a little more on that section. So first off, the first section we hit on this for this test is section 3.1, which was the quadratic section. So I'm going to go over, make sure I don't miss anything on this section. My book kind of situated. 3.1. Yeah, the quadratic formula. Or not quadratic formula. 3.1 was just on the quadratic function. Okay, the quadratic function. And remember, there were two forms or two ways to write the function. We have to know both ways and how to find all of these things from that. With the quadratic function, you need to be able to find the vertex. Remember, it was two different ways for the standard or the general form that we talked about. But we've got the vertex, we've got the axis of symmetry. Axis of symmetry, the domain and range, the x and the y intercepts. And I believe that was it. Let me make sure. I'm going to go through and kind of, vertex. And really, I mean, if you want to say overall how to graph it, remember this is going to be multiple choice. So I'm going to focus more on these first four. Graphing might be a question on there, and it'll be a lot like the last section where, you have to graph it out of the equation, but you guys have calculators. I'm not too worried about graphing. It's finding these four items from the actual function. So if I gave you the function, find the vertex, axis of symmetry, domain and range, and the x and y intercepts, all from that function. And I'll tell you some good homework questions to look at. that really hit these well. Just saw them. Where in the world? Vertex, intercepts, graph. Yeah. This would be just to get two different examples. This is on page 343. It'd be like homework number 17 and then 29. Those two would be good. And now look, I don't think they ask you to graph it at the end. I would just go ahead and graph it just so you can kind of see what it looks like and see how everything goes together. Okay. 1729. And then also 39 would be a good one to throw in there as well, where it's asking you a few more things about it. But that homework, I mean, if you're struggling with quadratics, you can just go through that homework. It's very straightforward. We went over it. I feel like we did a good job in the lecture about going over what's going to be on there. But that's the main, really 5 topics from that section. Your book definitely goes a little more in depth on some of the stuff. Okay. So any questions about section 3.1? So we're not get some water. Any questions about 3.1? Really, I'll tell you, 3.1 is kind of on its own. 3.2 through 3.3, or I'm sorry, 3.4. 3.2 through 3.4, it's kind of hard to say, are really lumped together more. So let's start in 3.2. It was really an introduction to the polynomial. Introduction, let's say, to the polynomial function. Introduction to the polynomial function. And the first thing your book goes over is end behavior. And that will definitely be on the test. It's on the final as well. Actually, all this stuff's on the final and on this test so far. The end behavior, which really is just using the leading coefficient test, right? But it's really about the end behavior of the graph is the first thing your book goes over. And then it goes over finding zeros where we just have to factor it completely and find it. It's kind of like the intro to it. Finding zeros is going to be in 3.2, 3.3, and 3.4. Okay, but I'll kind of mention it here because it's the first time you had to find zeros. But if you remember back, these were all easy zeros. This was like, -1, 4, and 3. Okay, this was the easy stuff when it came to finding zeros. But it was like the introduction to finding zeros. I'm going to say, and their multiplicity. Multiplicity got brought up here. And multiplicity had to do with if we had repeating zeros, right? If we had 2 zeros, it bounced off the graph. If we had an odd amount of zeros, it went through the graph. That was brought up. And I would look back in this section in 3.2 and go over that multiplicity if you're like, I don't know what he's talking about. But it's on page 354. Is multiplicity, 354. It's one of those things that probably will pop up on the test that if you know it, it's easy. It takes 2 seconds to solve, right? But if you don't know it, you're just kind of lost in space out there, okay? I didn't go over the intermediate value theorem. That's fine. And then graphing. Yeah, graphing a polynomial. And this is a very basic graph because we haven't gone over any real in-depth polynomials like zero, imaginary zeros or rational zeros. We hadn't got to them yet. So this was kind of the easier graphing version where you had to find the end behavior, find the zeros, know the multiplicity, and then you could graph because of that. Okay, you could graph out of it. And for homework, this is on homework I'll kind of focus on for like a study guide. Page 360. Homework, I want you to look at number 19, 23, 25, 31. I'll choose the odds so you have the answers. Yeah. And then, so for these last two, you don't have to look, these last two have a part A, B, C, D, and E. You don't have to do D. I'm not going to ask you about the symmetry. So really just A, B, and C is what I want you to do on these last two. So let's say 41, and let's do an even one. Say 41, I'm not even, an even degree. Let's do 49, 41 and 49. Those are two different kinds. But for these two, just do A, B, and C. Okay? For those, just do A, B, and C. So intro to polynomial functions. So we learned about end behavior first. Remember, they're smooth and continuous, right? They just do something like that, or maybe they go up and then down, or they're smiling, or whatever. But it was an intro to finding zeros where we just had to factor. In this section of 3.2, we just had to factor to find all the zeros. And then introduce multiplicity. And I'm telling you, I would look at that again. And then the graphing, once we know all these three things, we can graph the polynomial, really do kind of a rough sketch of the polynomial. Okay. So 3.3 brings up, first off, it was just dividing. Actually, I think they might even title it that way. Yeah, dividing polynomials. Ooh, dividing. So first we went over dividing, we did synthetic, and then the remainder theorem. So dividing polynomials and the remainder theorem. Dividing, again, we did synthetic. And so mainly, for the first part, it's just knowing how to divide synthetically and then how to state the quotient if it has a remainder or if it doesn't have a remainder. And if you did that section, you'll know exactly what I'm talking about. And it's not hard. Again, this isn't that hard if you know what you're doing. If you don't know what you're doing, it's an easy question to miss on a test. Well, really, I was going to say dividing synthetically. Synthetically. I should divide polynomials synthetically. Synthetic. Synthetically. I don't know. We'll leave it there. Divide synthetically. And then your book went over, actually, the remainder theorem. They go over the remainder theorem. And then it introduced finding the zeros in a little higher, a little more of than just a baby kind of spoon feed, where it said, look, if I gave you a zero, find the remaining zeros. So given a zero or a solution, remember they call it zero, solution, root, all the same thing. Given a zero, find remaining zeros. Given a zero, find remaining zeros. So these are really the three concepts from 3.3. Dividing kind of took over. That's really, if you go back and look at the lecture, the biggest chunk of that lecture is just over how to divide synthetically. And it's not that hard. Once you get the pattern, it's a very, dividing synthetically is a very efficient way of doing something. It feels like waving the magic wand to get an answer, which is it's a pre-calculator thing, right? Where the goal in a lot of mathematics, once you kind of discover something, it's how to make it quicker, how to do it faster. And that's really what synthetic division, that's how it came about, is they whoever back in the day found patterns that made it that we could do this quicker than just doing long division. Remainder theorem, remember, was just if you plugged in an x value and you got back zero, must mean that that's a zero of the function, or whatever you got back actually was the remainder if you divide it out. And then given a zero, find the remaining zero. So for the homework that I would focus on, page 374, the homework I would focus on would be like number 17. This is just dividing. 17, 21, and then let's do like a weird one. Let's say 25. Doing missing terms. Let's say 29. Super weird. And then, so that's the dividing synthetically. Then we get into the remainder theorem. So that's like 33 and 39. Those are good remainder theorem questions. And then lastly, the given a zero, find the remaining zeros. That's 41, 43, and 45. And I'm giving you a few more of those per se because this is really the intro to section 3.4. Okay, that's an introduction to section 3.4. Okay. Okay, and then lastly, 3.4, which really should just be called finding zeros. Yeah. This is the one where I missed class, but you guys were watching the lecture from the Wednesday class, actually, when I made the lecture. First off, we talked about the potential rational zeros. Where you had to use the factors of the constant and factors of the leading coefficient. And you kind of have a pool, right? A pool of all the potential rational zeros. And from that pool, you can kind of decide what where to go to find the first zero and then divide it out and go through the whole process. So I'm going to say from here on out, after the potential rational zeros, you're just finding all zeros. Okay, finding all zeros, and there's really only, I mean, it's just, that's it. Your book goes over like Descartes rule of signs, and I think in that lecture, if you watched it, I mentioned if you get on Descartes Wikipedia, it's very interesting. He's a very interesting guy, and yeah. Anyway, but he developed that rule of signs. You don't have to do that. That's not a big deal. But for the homework, from this section, it's on page 386. The ones I would focus on, first, it's just finding the rational zeros. So let's say number 3 and number 7. And then the rest is just going to be finding all the zeros or roots or solutions, however they want to say it. So I'm gonna choose different ones, but realize they're all found the same way. It's just one, or a few are going to start off as functions, a few are starting off as equations. Let's say number 13, number 19. I think I did 19 in the lecture too. Number 41. And number 49 as well. These are 3. Hold on. Yeah, these are all 4 good examples of finding zeros, and they're different types of examples. There's something different about all 4 of them. Okay, so that's why I'm choosing them for that section. Look, I haven't made the test yet. Again, I'm going to make it right after I make this lecture video. So by the time you're watching it, it might already be made, right? Unless you're following along live right now. But I will have it done within an hour or two, unless Blackboard or my laptop have something that needs to be updated. Okay, so you've got a lot of time right now, and I don't mind answering any questions at all. This time is for you. Is there anything over these 4 sections, through 1, 3, 2, 3, 3, and 3, 4, that you want to ask me about? So that the test will be open. The test needs to be, it'll be due by Thursday. Thursday at 11:59 p.m. Now, if you're in the Monday, Wednesday class, we're going to go over the next section tomorrow. Okay, but you'll still have Wednesday and Thursday to take the test, but we just have to keep rolling. Okay, so if you're in the Wednesday class, I think we'll go over 3.5 tomorrow, and same with the other class. You guys in my Tuesday, Thursday, we'll go over 3.5 on Thursday as well. But realize the test isn't due until Thursday at 11:59 p.m. Questions? I'll tell you, overall, students, do better on this test because all four of these sections really do kind of go together. 3.1 is kind of on its own, but 3, 2, 3, and 4 are really meld together well. They kind of build on each other. So it's not like a few of the previous, especially the first one. First test is kind of all over the place. These four sections go together well. I don't typically see my worst grades on this test, but that doesn't mean it doesn't happen. Don't just assume you can't. You shouldn't. It's not easy material. I'll put it that way. It's not the easiest. This is not the easiest material to know, but also it's not the. It's nice the way the book kind of presents it in the section orders. Do you have any questions, Charlie?
I have a question.
CJ, you're gonna have to speak up or get closer to the microphone because I can barely hear you.
Sorry.
That's okay.
Can you go over one of those questions that you put on there that talks about finding all the zeros?
Like the one at the very end?
Yeah.
Yes, let's do that. I'll do an even one. I'm going to show you how I would tackle it. Okay. So let's say we had, we'll do 51. It's one of the harder ones, I guess, because it's at the very end. But we've got 2x to the 5th. Oh yeah, this is going to have like everything. Okay. 2x to the 5th plus 7x to the 4th minus 18x squared minus 8x plus 8. So before I even get started, I need to realize I've got a missing term here. You see there's no 3, right? There's no x cubed term. I need to know that when I start dividing off. And before I get started as well, I've got 5, a degree of 5. So that tells me I'm going to have 5 solutions here, right? Now, some might be repeated, but I do have 5 solutions going on. This is going to be probably way harder than the actual test. So it's good. If we can do this one, we can do the easier ones. Okay. And then let's go over kind of part A and B. A, I'm going to ask you for potential zeros, right? All the potential zeros. If you did this, we know it comes from 8. So we have 8, 4, 2, and 1. And then the leading coefficient's 2, so 2 and 1. And there's going to be a lot going on here. So I like taking the first factor and dividing it by both. I'm going to do this in one step. 8 divided by 2 is 4. 8 divided by 1 is 8. And then I go to 4. 4 divided by 2 is 2. 4 divided by 1 is 4, but look, we already have that here, so I'm not going to repeat it. So then I go to 2. 2 divided by 2 is 1. 2 divided by 1 is 2. It's already there, so I don't have to worry about it. 1 divided by 2 is 1/2. 1 divided by 1 is already there. So I wound up with 1, 2, 3, 4, 5, really 12 potential zeros, right? 12 potential zeros. And I've got a 5. I know I'm going to have at least one of these as a 0 because remember the irrational, I should say. Remember, these are all the potential rational zeros. The irrationals always occur as a pair. So since I have 5, I know I'm going to have at least one rational number as a 0. I'll probably have 3. But let's look at this now. So the very first thing I'm going to do, so now it's going to say find all zeros. Probably going to need 2 pieces of paper for this. The very first thing I do, CJ, is I graph this thing. And I brought my calculator this time. My son had to use it for the PSAT and when I made that lecture. And it's like the first time he's ever had to borrow my calculator, and it was the day that I really needed it for the lecture. So I'm going to go in here. I'm going to go to y equals, and I'm going to put this equation in. 2x to the 5th plus 7x to the 4th minus 18x squared minus 8x plus 8. Now look, even though this was written as an equation, I'm going to treat it like it's a function, okay? And then I'm just going to graph it. So I hit the graph button. It's going to take it a minute because it's kind of a big equation. Well, oh, there it goes. Okay, yeah. Let's see here. If you want to zoom in, you can hit the zoom button. Still graphing it. Still thinking. Zoom in. And then I'm going to just hit enter to get it. Or just enter once. See if I can see what's going on here. Then it goes up. I'm not worried about where it crosses the y-axis. I know that's just going to be 8. It's coming down. Okay, check this out. I'll do a zoom in here. Notice at x equals -2 here, it bounces. Do you guys see that? So it hits twice. So what that tells me from my graph, so this is all, I'm getting this all from my graph. From the graph, x equals 2 has an even multiplicity. Even multiplicity. It's going to happen more than once, okay? So here's what I'm going to do. I'm going to divide 2 out twice because I know it doesn't have an odd multiplicity. If you go back and look at the other examples from 3.4, I don't think I did one with an even multiplicity. So this is great. This is an extra example. So I'm going to divide this out twice. So let's go back. Here's my original function. And remember, x equals 2 is the potential 0. Now look, if I go to my table, if you go to your table, and I can see, I'll do the function thing. If I go, oh, it's -2, isn't it? Yeah, it's -2. When I go to my table, -2 has a y value of 0. So that tells me that I'm right about -2 being a 0. Okay, so that's kind of neat. If you hit the table function, it does that. So go back to graph. So it's not positive, it's negative. And look, -2 is one of my options here, right? So we're all kind of lining up. It all works out. So I'm going to divide out -2 twice. So let's see here. I'm going to go slow with this. Remember, I have a missing cube term. So the coefficients would be 2, 7, 0, because 0x cubed, -18, -8, and +8. Okay? And then I'm going to do synthetic division. So bring down the 2, multiply it, add it, multiply it, add it, multiply it, add it, multiply it. Let's see here. What would this be? +4. Multiply it. Oh, yep. I got a 0 as a remainder. So it was right? I mean, all of this lines up. 0 as a remainder. The graph bounces at -2, and my table says -2, 0 is a coordinate, so it has to be a 0. Now, because of the multiplicity, I'm going to do this twice, but I'm going to tell you where we're at right now. Right now, what this tells us, if I think of this as a function, I factored out -2. Now, remember, that means the factor is x plus 2, okay? And I'm left with, look, I go 1 down from the 5. So 2x to the 4th plus 3x cubed minus 6x squared minus 6x plus 4. That's what I've done so far, okay? And what I'm trying to do is I'm whittling away at this function. We've gone from a 5th degree now to a 4th degree, okay? And we can think of starting this completely over if you want to. You can graph this and plug it in your calculator and try to find the last 4 zeros that way. There's nothing wrong with that. But because I know it bounced, I know there's another 0 hidden in here of -2. So I'm going to divide that out again, but from this 4th degree function. So 2, 3, -6, -6, and 4. Okay, so bring down the 2. -4, -1, 2, -4, 8, 2, -4, and 0. Yay, the crowd goes wild. Mr. Shirley does it again. Okay. But let's see now where we're at. I'm going to have to pull in another piece of paper. Okay. Where we're at now, same function. We already took this x plus 2 out. We've taken another x plus 2 out. And we're left with, now look, we had a 4th degree. We took out a 0. We're left with a 3rd degree now. 2x cubed minus 1x squared minus 4x plus 2. Okay, this came from right here. Okay, Dang, we're not even done yet. Guys, this is like the hardest one in this section. So don't freak out if you're like, oh my God. If you haven't done the homework, it's definitely not going to make sense. So go back and do some easy ones before you get here. But I'm going to kind of start over now. And I'm going to say, hey, given we have this function. Now remember, this is our original graph. Let me press a button so it kind of pops up there. That's our original graph. And those are our potential zeros up there at the top. So if I'm looking at this one, I'm going to be kind of lazy. To me, it kind of looks like 1/2 is a 0. Do you guys see that? It's not going to be a nice whole number because it doesn't go through any of the digits. And look, all of these, I know it's blurry, but all of these are whole numbers. Okay, if you want to know what it's like to wear glasses, to take your glasses off if you don't have glasses, this is exactly what it looks like to me. It's weird. Okay, but if you go back to this, it looks like 1/2 might be a 0. And there's a quick way to check this in your calculator. So I'm going to show you a neat way to do this in your calculator. If you go, I can't remember how to do it. It's been a minute. Yeah, if you go to calc and you hit value, so calc and then value. This is a way to make this test a lot easier. If you look, notice it'll bring you back to the graph, but it's asking you for the x value you want to find out. I think 1/2 is 0. And we know due to the remainder theorem, if I plug in 1/2 and it gives me back 0, that means that that must be a 0. So I'm going to put this in as a decimal 0.5. And notice my y value there is 0. So therefore, x equals 1/2 is also a 0. Yay. Now notice, I didn't think 4, negative 4, 8, or positive 8, 2, or positive 2, or 1, or negative 1 was a 0. Because if you zoom out on this, if you go back to standard, you'll see these lines, this graph, never goes through those values for x, okay? It never goes through 4 or 8, 4 or 8 are out here. It goes through negative 2, we know that already, it happened twice. But it doesn't go through positive 2, it doesn't go through 1 or negative 1. It doesn't go through negative 1/2, so it looked like it went through positive 1/2. It's kind of like a deduction thing, right? Well, it's got to be 1/2. Okay, so again, I can't see that on the table because the table does integers. Like if I go back to table, you'll see your table on the left, it doesn't include negative 1/2 because the standard way this table is set up is that it goes by just integers. So I'm not going to see it there, but by doing the second calc and the value, I can put it in and it gives me back y equals 0, right? It's y equals 0 right there for x equals 0.5. So now I'm going to go through this process with the 1/3 here. I'm not the 1/3, but the 3rd degree. So I'm going to divide 1/2 out. 2, negative 1, negative 4, and 2. Bring down the 2. 2 times 1/2 is just 1, right? Oh, that's 0. 0 times anything is 0. Negative 4 times 1/2, negative 2. Big smiley face. Okay. And the reason this is a big smiley face is because now we have a quadratic. Quadratics are our safety couch, right? This is a good thing. This is a really good thing. Let's see what we have now, though. So what we have is we took out the 2x plus 2's. And then we took out an x minus 1/2. And we're left with this. Now you can write it as 2x squared plus 0x minus 4, you're more than welcome to. You just don't have to write the 0 if you don't want to. But we can solve this one. Look, we have 3 of the zeros. I know one of them's repeating, right? But these are 3 zeros. I'm going to solve this last one now. 2x squared minus 4 equals 0. You can pop it in your calculator if you want, however you want to solve it. I'm going to solve it by the square root method. Add the 4 to the other side. Divide the 2. This works because there's no x value, okay? X squared equals 2. Take the square root of both sides, and remember when we do that, we have to attach a plus or minus, and boom. We've got our last 2 zeros. Now, just for fun, I want to get the estimate. I'm going to put in just see what the square root of 2 is. 1.41. So if I go back to my graph and I zoom in, look, you can kind of see that the graph goes through 1.4 or negative 1.4 there. And it's going to pop up here in a minute. Boop, and it goes through a positive 1.4 there. That was the plus or minus the square root of 2. Okay. It's irrational. So, of course, it's not going to come up in our potential rational zeros. That's not where it pops up. It's just what we have. So the zeros here are, okay, negative 2. It happened twice. You're more than welcome to write it twice. The test won't. Okay. So it'll just say negative 2. Positive 1/2, the square root of 2, and negative square root of 2. Holy cow, CJ. I'll tell you, the one on the test, not going to be this hard. Okay. It's going to be more like this one if I gave you this one as a function. And on the graph, you found out it was 1/2. You divide it out, and then you solve for the remaining quadratic. So you would have 1/2 square root 2 negative square root 2. But I believe I did one like that on the lecture. Like if you go back to the lecture CJ in 3.4, you'll see a more basic one like that. Maybe 2. I had to sit through a lot of stuff. Does that help, CJ?
Yes, that was awesome.
Awesome. Thank you. I aim to please, right? Okay. Do you guys have any other questions? Look, that's the hardest one. If you go back to the lecture and watch it, you'll see ones that and really, if you look at the ones I told you to look at for the test, they're not this complicated. Okay. They are not this complicated. Okay. I'll stick around for a little bit, but if you guys have any questions, or if you don't have any questions, you're free to leave. I'm gonna pause the live stream so it doesn't, so I just dead air.